The foods we consume are not just sources of energy, but also serve as the building blocks of the neurons that enable us to think, feel, and process information. Over time, the quality of our diet has a profound impact on the brain's structure and function. A growing body of evidence indicates that certain foods and dietary patterns can significantly enhance brain function, while others may be detrimental. This knowledge is increasingly vital as more people seek ways to optimize their cognitive abilities and preserve brain health as they age. Common questions arise about what we should eat and what we should avoid to maintain peak brain function, enhance focus, improve memory, and reduce the risk of cognitive decline. Understanding brain function requires acknowledging that we are really talking about the entire nervous system, which includes not just the brain's neurons, but also the spinal cord and the vast network of nerves that connect to every organ in the body. Neurons are the primary cells responsible for transmitting information, but they do not work in isolation. The overall health of the nervous system depends on multiple factors, including the quality of sleep, cardiovascular health, and the nutrients we provide to our bodies. Nutritional strategies that support brain health can be broadly categorized into two main areas: those that indirectly affect brain function by influencing overall health, and those that directly support the function of neurons. The first category includes general lifestyle choices, such as getting adequate sleep, staying socially connected, and avoiding or managing stress and depression. These factors are critical for overall health and have a profound impact on brain function, even though they may do so indirectly. The role of sleep in brain health. Sleep is perhaps the most foundational aspect of health, and its importance cannot be overstated. Regular quality sleep is indispensable for both mental and physical well-being. During sleep, the brain undergoes crucial processes that allow it to recover, consolidate memories, and clear out toxins. Poor sleep quality can impair cognitive functions such as focus, learning, and memory. Over time, chronic sleep deprivation has been linked to an increased risk of developing neurodegenerative diseases, including Alzheimer's and other forms of dementia. This is due in part to the brain's decreased ability to clear beta amyloid, a protein associated with Alzheimer's disease, during poor sleep. Therefore, ensuring regular, high-quality sleep is not just beneficial but essential for maintaining brain health over the long term. Cardiovascular health and brain function. Cardiovascular health is another critical factor in brain function. The brain is one of the most metabolically active organs in the body, consuming a significant amount of oxygen and glucose, which are delivered via the bloodstream. Regular cardiovascular exercise, typically 150 to 180 minutes per week, is essential for maintaining heart health. Healthy blood flow ensures that the brain receives an adequate supply of oxygen and nutrients, which are critical for neuron function and overall brain health. Conversely, poor cardiovascular health, which can result in clogged arteries and reduced blood flow, can starve the brain of the nutrients it needs, leading to cognitive decline. This connection underscores the importance of maintaining good cardiovascular health through regular exercise, a balanced diet, and, when necessary, medical interventions. Nutrients that directly support brain health. With the foundational aspects of sleep and cardiovascular health addressed, it is essential to focus on specific nutrients that directly influence the function of neurons. Neurons, or nerve cells in the brain, are the primary cells responsible for transmitting information throughout the nervous system. The health and efficiency of these neurons are critical for cognitive processes such as thinking, memory, and movement. One of the most important aspects of neuron health is the composition of their membranes, which are made up of fats, specifically essential fatty acids. The importance of fats in brain structure. The fats that make up neuron membranes are not the same as the fats stored in other parts of the body, such as those around our organs or under the skin. Instead, these are structural fats that form the double-layered membranes of neurons. These membranes are crucial for maintaining the integrity of neurons and facilitating the electrical signals that neurons use to communicate. The primary types of fats that make up these membranes are phospholipids and essential fatty acids, particularly omega-3 fatty acids such as EPA or eicosapentaenoic acid and DHA or docosahexaenoic acid. Omega-3 fatty acids, EPA, and DHA. Omega-3 fatty acids are vital for maintaining the structure and function of neurons. While most people consume sufficient omega-6 fatty acids, omega-3s are often lacking in the typical Western diet. This deficiency can have serious implications for brain health. Omega-3s are critical not only for the structural integrity of neurons, but also for their function. These fatty acids play a role in reducing inflammation, which is a key factor in many neurodegenerative diseases. They also support synaptic plasticity, which is the brain's ability to adapt and learn new information. The role of EPA in cognitive and mental health. Supplementing with EPA, a type of omega-3 fatty acid, has been shown to have a range of benefits for mental health. Research indicates that EPA can have mood-enhancing effects that are comparable to some antidepressants without the associated side effects. This makes EPA a valuable tool for managing depression, particularly for individuals looking to avoid the side effects of traditional antidepressant medications. For those already taking antidepressants, supplementing with 1 to 3 grams of EPA per day can enhance the effectiveness of these medications, potentially allowing for lower doses to be used. Beyond its role in managing depression, EPA is crucial for maintaining normal cognitive function in people who are not depressed. It supports overall brain health and helps protect against cognitive decline. Dietary sources of omega-3s, EPA, and DHA can be obtained from various dietary sources, with fish being one of the richest sources. Fatty fish such as mackerel, salmon, sardines, and herring are particularly high in omega-3s. Other seafood, including oysters and anchovies, also provide significant amounts of these essential fatty acids. For those who do not consume fish due to dietary preferences, allergies, or ethical reasons, plant-based sources of omega-3s are available. These include chia seeds, flax seeds, walnuts, and soybeans. While these plant-based sources provide ALA, another type of omega-3 fatty acid, the body can convert ALA into EPA and DHA, albeit less efficiently. For individuals who do not consume enough omega-3s through diet alone, supplements are a viable option. Fish oil supplements are widely available and provide concentrated doses of EPA and DHA. For those who prefer plant-based options, algae oil supplements offer a vegan-friendly source of DHA and EPA. Regardless of the source, aiming for a daily intake of at least 1.5 grams of EPA and ideally up to 2 or 3 grams is recommended for supporting cognitive function and overall brain health. Omega-3s and cardiovascular health. In addition to their benefits for brain health, omega-3 fatty acids are also known for their positive effects on cardiovascular health. Omega-3s help reduce blood pressure, lower triglycerides, and decrease the risk of heart disease. By supporting cardiovascular health, omega-3s also contribute to better brain function, as the brain relies on a healthy heart and circulatory system to deliver the oxygen and nutrients it needs. Although there is some debate over the ideal amount of omega-3s for cardiovascular health, the consensus is that a sufficient intake of these fatty acids is beneficial for both heart and brain health. Changing your relationship with food. One of the challenges many people face is changing their dietary habits to include more brain-healthy foods. For those who may not naturally enjoy foods rich in omega-3s, such as fatty fish, there are strategies to gradually shift preferences. Developing a taste for these foods can be achieved by experimenting with different preparation methods, combining them with other flavors, or starting with small amounts and gradually increasing intake. Additionally, understanding the significant impact that these foods have on brain health can serve as motivation to incorporate them more regularly into the diet. In conclusion, the foods we eat play a pivotal role in shaping the health and function of our brain. By prioritizing sleep, maintaining cardiovascular health, and ensuring a sufficient intake of essential fatty acids like omega-3s, we can support our neurons' structural integrity and functional capacity. These practices not only enhance cognitive abilities and mood in the short term, but also protect against cognitive decline and neurodegenerative diseases over the long term. As research continues to reveal the intricate connections between diet and brain health, it becomes increasingly clear that what we eat today can significantly influence our brain function and overall well-being for years to come.